This is our notes for lesson 2.3, day 2, piecewise defined functions. Our objective is to write a piecewise defined function given its graph. So it says, what is a piecewise function? It's a function that is a combination of one or more functions. The rule for a piecewise function is different for different parts or different pieces of the domain. So if you look at number 1 here, for this example, it says write a piecewise defined function for the function shown. And then we're going to determine the function's domain and range. So the first thing we want to do is we're going to write this as f of x equals, because it's going to be a function, and we're going to draw a brace, a big brace like that. Now all the parts are going to be written inside, and usually we like to go from left to right. So we're going to write the equation of each piece. So the first one, the first piece of the function we come to, it says y equals x squared. We don't need to put the y equals because we already have this f of x. So we're going to put x squared. And the next part is, well, where? How much of it is the x squared? So the x squared is going from negative infinity up to the number 2. But we see here there's an open dot. So it's going up to 2, but it does not include 2. So from negative infinity to 2, oops, we're going to have that piece. So negative infinity to 2. Now the next piece we see is this one dot all by itself. So we're going to write that as y equals 6. So it's just 6. Well, we want to know, what are the x values? What x value is at 6? So the domain for that is going to be when x is 2. And I don't need to put that in parentheses since I'm not showing an interval. So I'm just going to say that x equals 2. And the next equation that they give us is y equals 10 minus x. So that's the third part of our function, the third piece. And we need to figure out where is it in our domain? What x interval do we have? Well, it starts at 2, but it's not equal to it. And it goes as far as 2, 3, 4, 5, 6. From 2 to 6, not equal to it on either side. Okay, so now they're asking, what's the domain? So the domain, it started over here, it's going to go to negative infinity, and that's what we said here, is this starts at negative infinity, and it's going to go all the way to 6. So this is usually where it starts, and this is where it ends. And if we went through the graph, we see that the x's are continuously covered until we get to 6. So our domain, negative infinity to positive 6, and it includes that. And that's something that I should change here. Let's change this to be a bracket. All right, our range then, as we go from the bottom up, it starts at 0. And let's make sure that there's no empty spaces here. So that's covered. That circle is going to be covered there, and it's going to keep going up to positive infinity. So our range is going to go from 0, and it includes 0, up to positive infinity. Okay, taking a look at our next example, we have two lines here. So we're going to start with our function f of x equals, and our brace. Okay, but we need to write the equations of these lines now. So what we need is a y-intercept. So for this first one, b is equal to 1, and we need a slope. So it goes up 1 over 1, up 1 over 1, so our slope is 1. So this line here is going to be y equals 1x plus b, or y equals x plus 1. Okay. Our second line, if we continued the line up, our y-intercept would be 0, and our slope, up 1, backwards 1, up 1, backwards 1, so our slope is negative 1. So for this equation, we're going to have y equals negative x plus 0, or just y equals negative x. So we wrote our two equations, and I'm going to go from left to right, and the first one we come to is this y equals x plus 1. So on this side of the brace, I'm going to put x plus 1. Now we also need to know from where to where. So it goes from negative 4, and it's equal to it there. And it goes up to a positive 1 in the x direction, and it's equal to it there. So that's my domain over here. So let's put the interval from negative 4 to 1. Okay. And the second equation, we have y equals negative x. Okay, now we want to know where. Well, it starts at 1, but it's not equal to it. So it's going from 1 to 3. And at 3, it is equal, so we can put our bracket there. So I'm going to add that interval over here. So the function takes on the form f of x equals negative x from 1 to 3. Okay, our domain, as we go from left to right, we go across, we start at negative 4, and making sure everything's covered here. That is, it's going to end at 3. So we're going to go from negative 4 to 3, and both sides are included. And our range, at the bottom we start at negative 3, and it goes up to positive 2. I have an open circle here, but it's covered by this piece of the graph. So it's continuous from negative 3 to positive 2, and is equal to it at both ends. Okay, the examples we have on the back of our notes, number 3. Okay, even though we don't see it on the end of these lines, when they look like this, there's supposed to be an arrow. There's supposed to be an arrow on that one and an arrow on that one. And again, we need to write the equations of these lines. So for the first one, I have 2 points. Well, if I have 2 points, I can find the slope, and then I can find the equation of the line. So let's start with our slope. So m equals y2 minus y1, so 2 minus 4, over x2 minus x1, 3 minus 1. So we end up with a negative 2 over 2, or negative 1. And our y-intercept is 5. So this first line we come across is going to be y equals negative x plus 5. Okay. Our second line so we have this point and this point. So let's find our slope. So y2 minus y1 over x2 minus x1. So on the top we're going to have 1 and on the bottom we have 2. So our slope is 1/2. And, well, they don't show us the y-intercept, so we don't have our b value. But we're going to pick either one of these points and plug it into the point slope formula. So let's do y minus 0.5 equals, so y minus y1 equals our slope times x minus x1. So y minus 0.5 is equal to 0.5x minus negative 3.5, or negative 1.5. So let's add 0.5 to both sides. 0.5. So y equals 0.5x minus 1. Okay, so this one here so it's going to be our equation of our second line. Okay, so we're going to write this as our piecewise function then. Well, before we do that, let's look at our intervals. So this first one, it's going to start at negative infinity, and it stops at 3, but it's not equal to it. And then the second piece starts at 3, and it's colored in, color dots, so it is equal. So 3, and it's going to go to positive infinity. Okay, so I'm going to write f of x equals, and draw the big brace so it can show all my functions, or all the pieces of my function. And the first one was this one here. So we need this negative x plus 5. And the interval is negative infinity to 3. And the second equation is y equals, we need this piece here, 0.5x minus 1. And that's going to go from the interval 3 to positive infinity, including 3. Okay, and our last equation on there. Let's look at our last piecewise function. Number 4, okay, we would have an arrow on the end here, and this is an arrow here. So the first one we come to, if we kept going with this line and following the points up, we would have a y-intercept of 0. It doesn't, but we need that to write the equation of the line. Our slope, up 1 over 1, up 1 over 1, is 1. So this one right here, y equals 1x plus 0. So y equals x is our first part. And its domain, it starts at negative infinity, and it goes up to -1, and the circle is colored in. So we're going to put a bracket there. Okay, the piece that is up here in the graph, we're going to do that 1 second, and it is just the equation y equals 3. It goes through the y-axis at 3, and it goes through from -1 to 2, and it has open circles at both ends. So these tell us it's not equal to it, so we put the parentheses. And the third piece of our piecewise function, let's see, we could continue this one up, and it's going to have a b value of 2, and our slope, up 1, back 1, is -1. So putting all that together, we get y equals -x plus 2. And it starts at +2, and it's equal to it because it's colored in. And it's going to go off to positive infinity. So now we have the 3 pieces that are shown on this graph and our 3 pieces of the domain. So I'm going to write f of x equals, and our first piece, we just need what's after the equal sign. So x, and that one's going to go from negative infinity to -1. And the second piece that we come to is y equals 3. And that's over the interval -1, 2. And then our last piece is -x plus 2. And that's over the interval 2, infinity. Okay, for both of these, we need to go back now and find the overall domain and range. So for this first one, if we go across, negative infinity is where it starts, and it's going to go to positive infinity. And if we notice here, that's what our piecewise function shows, is that we start at negative infinity, and it goes through to positive infinity. So our domain is negative to positive infinity. Our range, okay, this is where we have to do some checking. So it starts at 0.5 in the y direction, and it keeps going up. Here's an open circle, but it's covered by this line. And then we're going to go up to positive infinity. So our range is going to go from 0.5, and it includes that, up to positive infinity. And the same for our last one on there, number 4. let's look at our domain. Furthest left over, negative infinity, and everything is covered as we go through, and it's going to end up at positive infinity, which is what we show here, is that we're starting at negative infinity and we end up at positive infinity. Okay, our range down here as we go up, we have these down arrows, so we know we're coming up from negative infinity, and it's going to go up as high as 3. And there are parts here where it is equal to 3. Okay, and that gives us those 4 piecewise functions. So this whole, all 3 pieces here is considered one function. Okay, at the bottom of the page here we have our homework. Let's see. Our homework is on pages 84 to 86, numbers 7 through 10, 22 to 24. And also remember, we still have the benchmark assessment, and that's on Buzz. Needs to be taken by midnight Friday. Set aside a good 40-minute to 60-minute time period. And also tomorrow on Wednesday, and that's going to be 9/2, there is a quiz on Buzz. Okay, Wednesday's open for tutoring. If you need to have tutoring, indicate that on the playlist that you will find on Buzz. Sign in on the playlist and show up for tutoring Wednesday. There's the quiz and also a benchmark assessment that is due by Friday. And don't forget, there is homework from your textbook. Okay, see you in a few days. Stay safe, and we'll see you later. Bye.